Hello student, let's start with the next topic of our syllabus, that is nothing but a reflection of light from the plane surface. So what exactly we have to prove here? If you remember, in last part we have started with the hygiene principle. We have learned that hygiene principle. Apart from that, we have seen the construction of plane wavefront and spherical wavefront from hygiene principle. Now in this topic we have to see the reflection of light from a plane surface. In this case also, how the light get reflected, that we have to learn, and while doing this we have to use application of hygiene principle at some places. Let's start with the setup for this. So let's start with this reflection of light at a plane surface. How the light get reflected at the plane surface, that we have to learn. Let's start with this MN. This MN is a plane reflecting surface, so that we have drawn here the lines at the bottom, so it becomes a mirror, we can say. So it will reflect light as light instead on this plane surface. It is reflecting surface, so it will reflect the light. Whatever the light incident on this, it get reflected by the same. Now here we have to learn about the reflection of light. Now here, if you see in this diagram, we have considered a plane wavefront. Let us consider a plane wavefront AB. So this is A here, this is B here. So this plane wavefront is coming here. It is incident on this reflecting surface. Now here, plane wavefront AB is bounded by the light rays A, R and BQ. A, R and BQ are the light rays which will bound the plane wavefront. Now this AB is a plane wavefront incident on the plane surface MN. It is seen that when it comes like this, it try to incident, just suppose this like this plane wavefront. It comes like this. Initially one end, that is A, meet the reflecting surface. When end A is meeting the reflecting surface, at the same time the B end of the plane reflecting mirror, or we can plane wavefront, A surface of the plane wavefront instead on the reflecting surface, at the same time B is here somewhere. So at the same time both of them never get reflected. So at one time, one end A gets incident on the reflecting surface, B remains at certain height above it. Now let us consider the velocity of the wave is V. Velocity of this plane wavefront in this medium is V, and time taken is T. Then the distance traveled by this is nothing but a distance traveled by the plane wave front having a velocity V, in time T is V into T. So suppose you can take this as capital T or small t. So let's take a capital T. So according to your book, it is capital T. So we go with a capital T. So how much distance it will travel? V into T is the distance traveled by the light waves when it incident from this medium. Medium is same. Now let's start with here. When the end A of the plane wavefront incident on the plane surface, end B is here. Now let's start with this. Suppose after B, we start counting the time. After this distance V into T is the distance travel further. So B and C, this distance must be V into T. Why it should be V into T? Because we have considered time T and plane wavefront is traveling with a velocity V. So it will cover a distance Vt in a time T. So it will reach from B to C. But when this end reaches from B to C, what will occur to the end A? A is already reached. So what will occur to the end A? A gets reflected back because it is reflecting surface. It is reflected back in the same medium and it will travel further in the time period capital T. So where it goes after reflection. So this is reflected wave. See, this is reflected wave. So when A is here, B is here. After time T, what will occur? A get reflected from A. It will reach to the point E. Within this same time, B will reach to the point C. Because the medium is same, if this BC is VT, then AE merge BVT. Because within this time T, it will travel to the E. Within the same time, another end move from B to C, it is a move from A to E. And that is said to be reflection of one end of the plane wavefront. Now let's do one thing. Let us draw a arc. Let us draw a arc with A as the origin like this, whose radius is V into T. I have drawn it like this. Name the point E. So we can say within a time period T, A reflected to the point E and B travel from B to the point C. Okay, so that would be the theory. Now let us do one thing. Now the point B reached to C, A reached to E. Draw the line connecting to this point E and C. So this is the line E and C I have drawn. So this E and C is what? A reflected wave. This is nothing but an incident wave, and this is nothing but a reflected wave. So this is a reflected wave from the plane surface, reflecting surface. Now here the concepts are what? Here if you consider, if you draw the normal to this, at point A I have drawn the normal AP. If you realize this dotted line, AP is a normal drawn from point A. Now angle between incident light ray and this normal, that will give the angle of incidence. So that is nothing but I, angle of incidence. If this is I, then this angle BAC merge BI. BAC merge BI according to geometric rule. Similarly, at the same time, angle PAE is angle of reflection. If it is R, then ECA merge BR, again by using the rules of geometry. Now let's see here, there are two triangles. Triangle ABC, triangle ABC and triangle AEC. These are the two triangles. In these two triangles, their hypotenuse is same. So this hypotenuse is AC, which is same in both of them. It is common. Apart from this, BC is VT and this AE is VT. So we can say two sides are common. When we have the two triangles whose two sides are equal, the third side must be equal. So we can say these two triangles are congruent triangle, similar triangle we can say. If these two triangles are similar, then we can say angle BAC must be equal to angle ACE. But what is BAC? BAC is angle I. And what is ACE? AC is the angle R. So we can say here angle of incidence must be equal to angle of reflection. And here if we see in the diagram, incident light ray, reflected light ray and the normal lies in a vertical plane. So this is the condition for Snell's law. So we can say Snell's law of reflection is valid in this case. Now remember what we have done, we have just explained this reflection of light at plane surface by using hygiene principle. What is the hygiene principle then? Hygiene principle is that when the light ray incident on this, it behaves as a reflector. It will reflect the wave in all possible direction. So it will reflect. And this wave we have drawn, then reflected wavefront we have drawn. EC is a reflected wavefront, AB is an incident, EC is a reflected wavefront. So that part we have done. So we finally conclude that angle of incidence is equal to angle of reflection, and all incident light ray, reflected light ray and normal lie in the single plane. What does it mean? It means it will obey the laws of reflection. So this is nothing but a simple concept we have explained by reflection. Now the next one is what? Refraction. That point is eliminated from your syllabus this year. The next topic is polarization of light. That also reduced in this year. Now directly we go to the next topic, that is nothing but what? Interference of the light. How the light get interfered with each other. Now might be if you are well known about interference means what? Whenever we are speaking to someone else and some third person comes into existence and that third person try to disturb us, then we can say to that third person that why you are interfering in us. Similarly, if you remember, we have learned in 6th chapter principle of superposition of wave. If you remember, principle of superposition of wave we have learned in the 6th chapter. What exactly that principle of superposition of wave? When two or more than two waves arrive at a point simultaneously, they will produce their own displacement independent of other, and the resultant displacement is sum of the displacement produced by each wave independent of other or each wave separately. That part we have learned. That is principle of superposition of wave that we have learned. Now interference, just if you see, I have drawn one for sake of understanding. I have drawn one diagram here. Suppose there are two sources of light. This is source S1, this is source S2. Sources of light I am saying. In your book they assume that there are 2 points S1 and S2 where we can drop stones. When we drop a stone on the water surface, what will occur? It will produce waves. And that waves they have shown here. So S1 and S2 are the 2 points where we have dropped 2 stones at the same time. What will occur? They will produce their own waves. After some time, the wave travel to the edges and the two waves try mixing together. mixing together, and that mixing of two waves is said to be interference of light. Now what type of mixing would be there? The mixing may be, suppose if you remember we have drawn here, suppose I have drawn such type of wave, it is said to be creased, if you remember, and this is said to be tuff. So creased and tufts are formed. So when creased of first wave fall on creased of second wave, creased of S1 fall on creased of second S2, as well as tuff of S1 fall on tuff of S2, what will occur? The two waves interfere together, mix together, and they will produce what? Bigger wave. They will produce a bigger wave. So this plus another, so it will be double. So the bigger construction will be there, and that is said to be constructive interference. When creased of first S1 fall on creased of second S2, as well as tuff of first fall on tuff of second, resultant intensity or amplitude of the wave increases, and that is said to be constructive interference. Apart from this, exactly opposite to this, suppose creased of first fall on tuff of second, creased of first fall on tuff of second, as well as tuff of first fall on creased of second. What get occurred? This is the first part, creased and tuff. Second part would be like this. So this would be tuff, this would be creased. When tuff fall on the creased, creased fall on the tuff, this part cancel with this part cancel with this. If there is a cancellation of this, what would be the resultant intensity? Resultant amplitude decreases, as well as resultant intensity also decreases, because we have learned intensity is related to amplitude, intensity equal to amplitude square. There is a relation between intensity and amplitude. So amplitude reduce means intensity reduce. And that case, when creased of first fall on the tuff of second, the tuff of first fall on the creased of second, so that resultant intensity decrease, amplitude decrease, that is said to be destructive interference. Same, just I have tried, suppose there are two light sources S1 and S2. Suppose S1 and S2 are both are the light sources, they are emitting a same frequency light in all possible direction. So this dark black line I have drawn, this is suppose creased, dark black line, this is nothing but a creased, and this faint dotted line, it is suppose tuff. Now here the dark line represent creased and the dotted line represented tuff. What will occur? When creased fall on the creased, dark line of this and dark line of this get matched together. That is said to be creased fall on the creased. When the dotted line of this match with the dotted line of this, we can say tuff match with tuff, constructive interference. So let's start with the point of constructive interference. So let's see, here I have drawn here some blue points. If you see the blue points are here, let's start with once again, doesn't matter. So see here, this is the dark line, this is again the dark line, dark and dark matching here. So this point must be bright point. Bright means intensity increases, and that is nothing but what? Constructive interference. Similarly, this is dotted line, this again dotted line, they meet together here. So this is a blue line, blue dot I have given. So this must be what? Tuff fall on the tuff, that is again constructive interference, bright point. So here constructive interference. So these are the points for constructive interference. So I had drawn this black line. So this is the black line for bright point. If the bright points are there, intensity is maximum, or we can say the constructive interference occurred. Let's go to second part. If we see this part, here the dark line comes, this dark line incident on the dotted line. So this should be what? This should be point represented by black circle. That is nothing but dark point, destructive interference. Why it is destructive interference? Because this crease of first fall on the tuff of second. So it becomes destructive. Again, if you go here further, suppose if you go further here, so this is crease of second fall on tuff of first. So again, this point is a minimum intensity point or destructive interference point. Again, this is a tuff of second fall on a crease of first. So we can say that this is again the destructive interference. So I have drawn this blue line, that is for dark points. Dark points means what? Destructive interference. In the same fashion, in your book they have done very well. So just look at the diagram, figure 7.9 from your book, which will represent you the constructive and destructive interference. Bright and dark points are formed. Apart from this, the next topic of the syllabus is what? Coherent sources of light. Same thing we are going to learn in Young's experiment. We are not going to see all these things. Just in shortcut that will finish that part, because same thing they have mentioned there. Let's start with this coherent sources of light. Coherent source of light. What exactly this coherent source of light means? The two sources we have considered initially S1 and S2. If the two sources are not coherent, we can't get steady interference pattern. We can't get well distinct interference pattern. So there is one condition that the two sources of light must be coherent. So what exactly coherent means? The two sources of light must emitting the light of same frequency and same constant phase difference. The two sources of light are said to be coherent if they are emitting light of same frequency having a constant phase difference and it is independent of time. Continuously they are emitting a constant frequency with a constant phase difference, then the two sources are said to be coherent sources. If the two sources are coherent, then we can say we get well distinct interference pattern. If the two sources are not coherent, then it is quite difficult to get interference pattern. The interference pattern some point becomes bright, at another instant same point becomes a dark. So that will be happen if the two sources are not coherent. So it is very essential for interference that the two sources of light must be coherent sources. Same thing we have to do further. If you take a two different sources coming from two light sources we have taken. Suppose this is S1 and this is S2. They are the two different light sources. Then light coming from them, definitely if they are in same phase, still there is a problem with, if they are in same phase, there may be problem with the frequency. If they have the same frequency, there may be the problem with the phase. That's why we can't get a well distinct interference pattern. That's why it is very essential to take a two sources of light that must be coherent. So there is one scientist whose name is Young, who has given the first experimental proof of this interference, and that was what he has done. He has taken a single light source. This single light source he has taken. He has kept one slit. He has given a two hole to the slit. So suppose this is one hole, he give the name S1. Second hole, he give the name S2. Now light coming from the single source will incident on this as well as this because it is kept at the equal distance. Then what will occur? Light coming out of this two holes of the slit. This act as slit 1, this act as slit 2, the two holes. This light and this light must have the same frequency because they are derived from single source. So they are said to be coherent. They have same frequency and constant phase difference, and these are the two S1 and S2 are said to be coherent sources. So these two are said to be coherent sources. Same frequency and constant phase difference, they are derived from the single source. So that was done by the first time by Thomas Young. So let's start with that Young's experiment. So we are not going in detail of the Young's experiment. Let's start with the Young's experiment. What he has done, that we have to see. So let's start. So Young's experiment, it is the first experiment to demonstrate the interference of light. Okay, so what exactly he has done, that we have to see. Just already I have told you, he has used a single source. Then what he has done, either we can just convert single slit having a two hole, or we can use here biconvex lens. So this light coming from this incident on it, and finally all this light incident on it get reflected, and we get here such type of plane lights from this. Okay, plane light we get. Now here what he has done, he has taken a slit, just drawn the two hole. Here it is S1, here it is S2. The light will come out from this, and now there is what, again suppose dark line of this creased, dotted line tough, again dotted line tough, again dark line creased, again the dark line creased, again the dotted line tough, again here the dotted line tough. Now let's see, dark line meet together, dotted line meet together here. So these are the point for constructive interference. So we can draw it like this. So bright point. So these are for bright points or constructive interference. Intensity increases, amplitude increases. What about this? This dotted line meet the dark line. This is the point of destructive interference. Same, dark line meet with dotted line, destructive interference. So these are the 2 points for dark point, we can say. Dark point means they are said to be destructive interference. Same thing. And finally here what he has done, he has kept here somewhere the screen. On the screen he will observe. So suppose this point goes like this would be the bright point, then this would be the dark point, again dark point, again bright point. So in short, this is an alternative formation of bright and dark point on the screen, and that is nothing but what? Bright for constructive interference, dark for destructive interference. In this fashion, here interference get occurred, and that was given by Young. So it is said to be Young's experiment, first experiment to demonstrate interference of light. So this is the first experiment which will demonstrate interference of light. Now let's go to the geometry of double slit experiment. Geometry means what? We have to draw some mathematical conclusion. When the point becomes bright point, maximum intensity point, when the point becomes minimum intensity point, that we have to learn about. So to learn about that point, what should we do? It is essential to draw the diagram. So I have drawn this diagram here. Let us start with this S1, the first source of light, slit, S2 second source of light, and exactly at the center of these two slits, exactly at the center, there is the origin O. Draw the three dotted lines. S1 to the screen, this is screen. S1 to the screen, it is S1 dash. S2 to the screen, it is S2 dash. Origin to the screen, it is O dash. Okay, and suppose the screen and the slit are separated by a distance capital D. This is capital D, separation of the screen and the slit, that are separated by a distance capital D. Is that clear? And the two sources S1 and S2 are separated by a distance small d. So that is a small d. If the distance between the two sources is a small d, then what would be the distance S1O? It is d by 2. S2O, it is d by 2, half of this, because it is exactly perpendicular bisector, exactly at the middle of these two. So the half of d by 2, d by 2. Okay, then let's see, here there is one point P. We have taken one point P. Okay, that point P is kept at a distance of y. So this point P is kept at a distance of y from origin O dash. So this O dash, distance of point P from O dash is y. Now we have to determine what? When this point P becomes a bright point, when this point P becomes a dark point, that we have to learn. So point P may be bright point, may be dark point. And now we have to draw the conclusion for what condition point P is a bright point or constructive interference get occurred. For what condition point P is a dark point, destructive interference get occurred. That we have to find out under this topic. So let's start with this. So here first of all, let us start with this. So let us consider a point O dash. When light ray coming from S1 O dash, S2 O dash, as it is perpendicular bisector, so this S1 O dash and S2 O dash, both the distance are same. If both the distance are same, what is the path difference? It is 0. If path difference is 0, point O dash is 100% a bright point. 100% it is a bright point. So point O dash is a bright point. Now we have to find out whether point P is a bright or dark in terms of path difference. So we must find out S2P minus S1P, that will give the path difference. S2P minus S1P give the path difference. Now here to find out this, we have to use the Pythagoras theorem, and here two triangles are there. S2 dash P. S2 dash P, first triangle. Second, S1 dash P. S1 dash P. This is the second triangle. And S2 dash P, bigger one. This is the first triangle. By using this, we have to find out S2P minus S1P. So I will write it here further. So we can write here S2P minus S1P square. S2P square minus S1P square equal to what? S2P square. S2P square equal to what? S2 dash square. Okay, S2 dash square means it is what? Capital D square. Capital D square. S2 dash is capital D square plus S2 dash P square means what? This is Y. Y plus D by 2 whole square. Y plus small d by 2 whole square. Did you got it? See, S2P, this triangle, Pythagoras theorem we had to use. Pythagoras theorem. So in this triangle, we have to use the Pythagoras theorem. So use the Pythagoras. Hypotenuse square equal to side square plus side square. Hypotenuse is what? SP, S2P, S2P square equal to S2 dash square means capital D square plus this distance. But already PO dash is Y. So y square plus d by 2, y plus d by 2 whole square. So that is nothing but S2P square minus S1P square. Same Pythagoras theorem. Now triangle become this. This triangle we have to use. In this triangle we have to go for this S1P square. What is S1P square? S1 dash square means capital D square. Capital D square. Here this is y. Y minus d by 2 is PS1. Y minus this d by 2. This is nothing but PS1 and that square we want. So plus y minus d by 2 whole square. So this will give the S2P square minus S1P square. That is nothing but a path difference. Now same we have to solve further for the valuation. So I will write down this to the next side. So I will just move my camera to this side. Just we have to write that same equation. I will write first, then we'll go further. Some modification it will require, and that modification we will do. Okay, so let's write down the same equation. S2P square minus S1P square equal to d square plus d by 2 y plus d by 2 y plus d by 2 whole square. So this is the first part, S2P square, plus second part d square plus y minus d by 2 whole square, that is S1P square. Now here S2P square minus S1P square, this left hand side can be splitted and that can be written in different way. So let's write down that in different way. What type of different way we have to use? Just we are going to use a mathematical formulas. What mathematical formulas we are going to use? So mathematical formula, a square minus b square is what? A plus b into a minus b. Same. So here we have to write S2P plus S1P into S2P minus S1P. So there, if you solve it, we get this according to mathematical formula. That might be you have learned up to 8th standard or 5th standard also. Let's go further. If we add these two together, so if we add these two together, what we give? What we get here is we get, if you solve it, we get it is 2y into d. Solve it. Just try to solve. Take it square, add it to this. Take it square, just cancel the common terms. We get here this as a 2 into y into d would be the remaining term. Just I would like to give homework. Try to solve this. This much comes twice by d. Try to solve it at your home. Those who don't have mathematics, they must solve. Those who have mathematics, they also try to solve it. It will come as 2yd. If it doesn't come, then just we'll see later on. So just if we solve these two brackets, we get twice of yd. So here I have written the twice of yd. What is our aim? We want the part difference S2P minus S1P. We want this. So move this to that side. So we can write S2P minus S1P equal to 2y into d divided by S2P plus S1P. Now S2P and S1P are nothing but what? These are nothing but what? If we see in this S2P, this S2P and S1P are hypotenuse. They must be greater than d actually. But up to first approximation, let us assume that S2P is approximately d, S1P is again approximately d. That is said that up to first approximation, both are supposed d. Then what will get here? Denominator S2P plus S1P, d plus d. We get twice d. So we can write this as 2y into d divided by 2 into capital D. 2 cancelled out. What we get? Y into d divided by d. So this is nothing but what? This is S2 minus S1, and that is said to be the path difference, and that was represented in your book by the letter delta L. So you can write delta L equal to y into small d divided by capital D. Path difference we have find out. So at the point P, path difference is given by this y into small d divided by capital D. Now point P is said to be bright point when this path difference is integral multiple of lambda. So that two conditions we have to draw. So let's draw that condition to this side, and let's see what are the conditions for bright and dark point. Bright and dark point. Let's start with this. So here I will make a two column, bright point, and the second column is a dark point. Now remember, bright point means what? Constructive interference, and dark point means what? It is destructive interference. So that conditions we have determined. So for bright point, what we say? I have told you, when the path difference delta L is integral multiple of lambda, then suppose delta L is integral multiple of lambda and lambda, suppose, then we can say point P is said to be the bright point if this condition is satisfied. Now let's put this value where n varies from n equal to 0, plus minus 1, so on up to infinity. Now let's put the value of delta L from that equation. It comes to be y into d divided by d equal to n into lambda. If this condition is satisfied, we can say the point is said to be the bright intensity point, or constructive interference get occurred, we can say. Same equation they have taken in your book 7.16, and that is for nth bright point they have taken, so they have just put here y suffix n. That is the only difference, because n lambda we have taken in general, so you should take it as yn. So this is a condition for bright point, and when this gets satisfied, we get this as a bright point. For nth bright point, directly we can find out this yn, distance, equal to what? N into lambda, capital D divided by small d. So this is a condition for nth bright point. Nth constructive interference pattern can we find out directly, n into lambda d divided by small d. This is condition for bright point. So this is a condition for bright point. When this condition is satisfied, point P at this distance, then there will be merged with the bright point, otherwise it would be dark. Now what is the condition for destructive interference? This delta L means what? Path difference must be odd multiple of lambda by 2, or we can say odd multiple of lambda, then it is said to be the dark point. Odd multiple of lambda means what? It must be equal to 1 minus 1 by 2 into lambda. Not a 1 minus, it is n minus 1 by 2 into lambda. Then we can say the interference is destructive interference, dark point we get. So put the value of this, so it is what? Y into d divided by d equal to n minus 1 by 2 into lambda. Now for nth point, it would be yn, so nth dark point, so yn dash, it is for dark point, na, equal to n minus 1 by 2 into lambda into capital D divided by small d. This will give the condition for dark point, destructive interference. Now if you find out the fringe width, fringe means this alternate dark and bright point we are getting an interference pattern that are said to be fringes. Bright fringes, bright points. Dark fringes, dark points. So these fringes are there. We can find out this fringe width, the distance between nearest consecutive, successive bright point or dark point. If we try to find out, that can be find out by one mathematical formula, and that is said to be fringe width. And that fringe width would be represented by W equal to yn plus 1 minus yn. Suppose this yn is a bright point or dark point. Next bright point is what? Yn plus 1. So distance between them, yn plus 1 and yn, that was calculated yn plus 1 minus yn. That will give the distance between the two consecutive bright point. Similarly, y dash n plus 1 minus yn dash. So that is a consecutive dark point, and that is said to be fringe width, and that was represented by W. If we put this value, put instead of n plus 1 here, and minus it with the same term, put same thing here, and just solve it. If you solve this term, it comes to be for bright fringes and as well as dark fringes, bright or dark point, this value comes to be lambda d divided by d. Fringe width come to be lambda d divided by d. For bright point as well as for dark point, this fringe width is same. Lambda d divided by d. This is for bright point as well as same equation would be there for dark point. What does it means? The consecutive or this alternate bright and dark points are equally spaced. Equally spaced means what? At equal distance. First bright point, equal distance dark point. Again bright point, alternatively equal distance. Equidistance, alternatively bright and dark points are placed in interference pattern. Now the next part, same topic. We are going to finish it now. Within 5 minutes we will finish. Now same point, this we have done. We have find out path difference, then we have find out condition for bright point. The path difference must be integral multiple of lambda. Condition for destructive interference, path difference must be in the odd multiple of lambda by 2. So that point already we have seen. Now same thing, the relation between path difference and phase difference can be given by, suppose path difference is given by delta L, phase difference is given by delta phi. How they are related? We can write here one equation. Delta phi equal to 2 pi by lambda, 2 pi by lambda, 2 pi by lambda into delta L. This is said to be phase difference. This is said to be path difference. So this is the relation between phase difference and the path difference. Phase difference and the phase difference and the path difference. Phase difference is related to path difference, and that are related to by this number 2 pi by lambda. So that they have mentioned. So we can put here the value of delta L. We can write this as delta phi equal to 2 pi by lambda into yd divided by d. This is the value of small l that we have derived. So this would be the equation, or we can write according to your book, yd divided by d into 2 pi by lambda delta phi equal to. So this equation gives the relation between phase difference and the path difference. And that was equation 7.21 in your book. Now same condition for constructive interference and destructive interference. For constructive interference, phase difference must be integral multiple of 2 pi. So delta phi must be equal to integral multiple of 2 pi, where n varies from 0 plus minus 1 plus minus 1 plus minus 2 so on up to infinity. So this is a condition for what? Constructive bright point. Bright point, that is said to be constructive interference. Similarly, what is the condition for dark point? It is delta phi equal to n minus 1 by 2, n minus 1 by 2 times 2 pi, or multiple of 2 pi. Now again here n, remember n should not start from 0 here. It is plus minus 1 plus minus 2 so on up to infinity. Initially the bright point, it is integral multiple of 2 pi. That's why it start from 0. Here it is odd multiple of twice pi. So just if you take, it is 1. 1 minus 1 by 2, it is 1 by 2. 2 cancel, pi. 1 pi is odd number. If you put this plus 2, 2 minus 1 by 2, 4 minus 1 by 2, 4 minus 1, 3 by 2. 3 by 2, 2 cancel, 3 pi. Initially 1 pi, then 3 pi, then 5 pi, odd multiple of pi. So that is the condition for, this is the condition for phase difference for dark point. So these are the condition for phase difference. Initially we have find out condition for path difference. So in this fashion, the constructive interference we have seen. Now intensity distribution point is remaining. Intensity distribution, I think the video is very much longer. We will take this intensity distribution in next period and we will start the next video. Now watch my video. After complete watching my video, try to understand the same, just try to read the same topic from your book. Definitely you understand very well. Still if you have the problem, feel free to ask me. Take care. Thank you. Let's see in the next video.